For today's video, I will be doing problem number 2 from section 6.6, which asks us to find the center of mass of a thin plate of a constant density, delta, covering the region bounded by the parabola y equals 3x minus x squared and the line y equals minus 3x. Now if we look at this here is just a graph of the two, just so I could get a visual. So this line here is the minus 3x, and this here is the 3x minus x squared. So first step in defining the center of mass is to set the two equations equal to each other and solve for x for the limits of integration. So when we solve for x, we'll get two values, and that will be our limits of integration. So in doing that, we just add 3x to the other side. And then we get 6x minus x squared equal to 0. And we can pull x out. And then we have 6 minus x. And then when we solve each one, we divide by x. We know that x is going to equal to 0. And when we set this 6 minus x equal to 0, x is equal to 6. So when we write that out on the integrand, it will be from 6 to 0. So our second step is to define for centers of mass x and y. And we know that when they showed this an example problem, they showed the graph that was similar to this with a parabola like this and a line. And they showed kind of a rectangular area like this. And it looked as if it was this was the center point, and it was just going to be toppling over on both sides. So here's half of it, and then the other half would be somewhere over here. And so x is just the constant is x, so this is equal to x. So it's kind of like an ordered pair. And then the y is going to be where we add the two equations and divide by 2, so the midpoint. So we're going to have 3x minus x squared plus minus 3x all over 2. And then when I simplify that down, because I can do the 3x minus the 3x, my point left is x comma minus x squared all over 2. So then, now that we know this, we'll use all these things we're finding right now, we need to use later to get our end result. So this is the x and this is the y. Next we need to find the area, so dA, and we need that so that we can solve for dm. So in area, the width is dx, and the length is just the 1y equation, which was y equals 3x minus x squared. Subtract that from the second equation, which was the minus 3x. And then when we solve for that, we get 6x minus x squared equal to the length. And then for dm, we're going to get delta times the area, so this is the area right here, times dx. So, messed that up, times the area. Width is dx. So we're going to have delta, and we're going to put our length, 6x minus x squared, and our width, which is dx. So all of these dm problems will have a delta, and then the length, and then the dx part right here, unless they give you a different value for that. Now that we know that, we can start solving bigger pieces. So we now need to find the y with this like tilde symbol over it, dm, and we do that by plugging in the dm and the y we found over here, which was minus x squared all over 2. So I'm going to write minus x squared over 2 times 6x minus x squared. And then that is going to, when I solve that all the way through, And we're just gonna, these stay constant, the delta is constant, the dx is the constant, so we just carry those through. So then when we solve this, we get minus 3x to the third plus x to the fourth all over 2 times delta times dx. And then for x dm, we have x squared. Wait, let me look at that. Oops, sorry, no, we have x, just x, because again we have the x here, which was our x value, so we have x times dm. So again, 6x minus x squared, and they're timesing the delta and the dx. And then when we rewrite that, we get 6x squared minus x cubed times delta times dx. Now that we have these, and all these values that we're finding, I'll put squares around them because we're going to need to use them for the next step of the equation. So all the things that we've figured out, I will just put some squares around them so that we can see that. Okay, next part is to find the moments and the mass. So this is the important part that we're really looking for so that we can find the center of mass. And all the equations for these, we have mass is equal to the delta dm, we have moment of x is equal to this, moment of y equal to this. All these I got from page 404 in my textbook. And so let's start with mass. We know the mass is delta dm. We know that dm was just delta 6x minus x squared dx. So then we're going to write, and we're integrating, remember, from 6 to 0. And then the dm is delta 6x minus x squared dx. And when I integrate that and simplify everything, delta is the constant, so that stays out in front, and I have it times 3x squared minus x cubed over 3 from 6 to 0. And then I need to evaluate that. When I evaluate that, I get 36 delta is equal to my mass. So the next is mx. So we take the integral from 6 to 0. Remember that y dm we solve for right here, taking the integral of this. So it's a minus 3x to the third plus x to the fourth all over 2 delta dx. And when I integrate that and then simplify all my terms, I get delta times a minus 3/4 x to the fourth, 3/4 x to the fourth, plus x to the fifth all over 10. Again, and that's from 6 to 0. And when I find my value for that, when I integrate and evaluate the value of the integral, I get delta minus times a minus 972 fifths. And the last part, my my for this, we're going to take this equation right here that we have. So we go from 6 to 0 of 6x squared minus x cubed delta dx, which then when we simplify all that down again and integrate it, I'm left with delta times 2x cubed minus x to the fourth all over 4, 6 to 0, which when I evaluate that integral, I get delta 108. Now, we're almost done. Last part, probably the easiest part, now that we found all the sections. To find the center of mass of xy, it is simply my over m, so over the mass. So the moment of y over mass, then the moment of x over mass. And we solve for all of these on this page right here. So my, was equal to, we'll start with that, my over m is equal to delta 108 all over our mass, which was 36 delta. Deltas cancel. And when we reduce that down, we get 3. And then mx over m, which is equal to a negative 972 fifths delta all over 36 delta. Again, deltas cancel, and then when I solve that and reduce it down, I get a negative 27 fifths. So our final answer for finding the center of mass of a thin plate of constant density over the parabola 3x minus x squared and the line minus 3x is, in ordered pair form, 3 minus 27 fifths for x and y. And that's how you solve problem number 2 from section 6.6.